Welcome back. This is problem number 5 from the 2019 free response question. And started off, I drew the drawing, did not shade it in because I wanted you to see R. Of course, you have this with you. Now, you don't have your calculator with you, and you're like, okay, they've given me two equations. How do I know which one is which? Well, if you look at the general form of it, look at what this has right here. Well, if you look at the highest degree of it, we're going to get a quadratic here, and then you're going to multiply it by a -2. So the leading coefficient on the quadratic is going to be negative. So we're talking about a parabola that opens downward. Well, looking at this is not a parabola that opens downward, but this is. So h of x is going to be the top equation. And just to confirm it, if you think about the cosine graph takes on this shape that's going to be consistent throughout. So we're looking here, and you see it has that shape. Of course, you also think back to what you learned in trigonometry. You've got 3 cosine, and then it's shifted down 2. So here would be 3 cosine, and it's shifted down 2. So we're pretty much confirmed on which one is on top of the other. So I'm using the zoom on my high quality camera. In other words, I just scooted my laptop in. But anyway, this is the integral. It's going to be h of x minus g of x. That's going to be how we're going to come up with the area. So now it's just a matter of integrating it. Now I'm going to do some stuff that's going to be combining like terms. I've got the 6 minus -2. That's going to be 8. And then it's going to be minus, and I've got this 2 times x squared minus 2x plus 1. And then from that, I need to put a dx here. From that, I'm going to be going from 0 to 2. I've got this minus distributed in with the 3, so I guess I need to erase that real quick. You can erase it with your finger if you need to. Minus 3 times the integral from 0 to 2 of the cosine of pi over 2x. Okay, so from here, looking at this one here, if we do a u substitution, we would let u equal to pi over 2x. So this would be pi over 2 dx. So that becomes, when you cross multiply to the other side, it's 2 over pi du equals dx. So we get this minus 2 times -3 is -6, so it's going to be minus 6 over pi times the integral. Okay, well, this is going to be cosine of u. All right, and now renaming our limits of integration here, we have 0 times 2 pi, which is 0. And then, I'm sorry, I did this wrong. Pi over 2. 0 times pi over 2 is 0. And 2 times pi over 2 is just pi. So we're going to be going from 0 to pi there. Okay, now back over to this integral. We're going to go from 0 to 2 of 8 minus, okay. Go ahead and distribute the -2 with the 1, and that's going to be 2. All right, then -2 with x squared is -2x squared. And then we get plus 4x. All right, so this becomes 0 to 2 of 6 minus 2x squared plus 4x. Let's just go ahead, for the sake of it, just go ahead and finish distributing this out, or integrating this portion out. So this becomes 6x minus 2x cubed over 3. That doesn't reduce, so it's just going to be 2/3 x cubed. And this becomes 4x squared over 2, which is just 2x squared. And we're going to be going from 0 to 2. All right, then it's minus 6 over pi. Now this is the This is the good news because we get a lot of this nasty stuff, but the antiderivative of cosine is positive sine. So we get times the sine of u from 0 to pi. So what happens here? We get 0 because the sine of pi is 0, the sine of 0 is 0. So all of this term becomes 0, so we don't need it anymore. So now we're just talking about 6 times 2 minus 2 cubed is 8, so this is 16 thirds. And then we have 2x cubed, or 2 times x squared. 2 squared is 4, so this is going to be plus 8. So we get 20 minus 16 over 3. Do not reduce it any further. There's a chance you could make a mistake. This is good right here. I watched a webinar last night, and they said that please do not try to do simplification because you do not want to miss points that are on it. So, and that's the way AP has always gone with their tests, but more important now than ever. You can have a calculator with you for the entire test, but there is nothing that if you have a calculator or you do not have a calculator, it will not be an advantage to you. A lot of people want a calculator there just for the confidence that goes with it. Now, this is part A to the problem. I'm going to do part B and part C next. I think I've got time to do it on this video. If I don't, I may have to do a separate video for part C. But part B tells us that we have this region that's going to come up perpendicular to it, and the area of each region is going to be 1 over x minus 3. That's going to be the area of each perpendicular slice. So what are we doing when we're getting volume? We're adding up all of the areas. So we don't really need h of x minus g of x here. All we need to know is that we are going from 0 to 2 of 1 over x minus 3 dx. Well, if your denominator is to the first power, then a natural log will work here. So the antiderivative here, in this part B, is the natural log of, and I'm going to put it in the absolute value. If this was an indefinite integral, you would definitely need the absolute value there. It's not necessary here because both of these, and I've got this wrong, this should be x plus 3 and not x minus 3. And we will be going from 0 to 2. So this becomes the natural log of 5 minus the natural log of 3. And you think, well, what's natural log of 5, natural log of 3? We don't know it, we don't know it, we don't know it. Well, that's fine. Natural log of 5 is a number. It's an irrational number. You do not have to give a decimal estimate here. The only way you could not leave this as a natural log is if you had a variable in there. If it's a natural log of 5x here, you would have to do something different with it. But for the purposes, as long as it was a definite integral, if it's an indefinite integral, you would just be able to stop there. But natural log of 5 is a number. It's good enough. You don't have to round here. Finally, part C. It says we're going to have this line up here that's going to be y minus 6. I'm sorry, y equals 6. And we're going to take this region and we're going to rotate it here. So my outer radius here is going to be, this is for part C, 6 minus this thing right here. We don't have to write all this out. We can just say 6 minus h of x. Or sorry, this is g of x. I would hate to miss a point because I wrote the wrong thing down. So it's 6 minus g of x. That's my outer radius. We're spinning it around, so it's a circle. This is the radius, so we square the radius minus the inner radius. Well, Again, this inner radius is going to be 6 minus h of x. And you don't have to write all that out. You can just say, hey, this is 6 minus h of x. And we go from 0 to 2, it's squared. And again, because it's circles, these are the radius, these are the radii. That's horrible grammar. So what do? The area of a circle is pi r squared, so we have to chunk a pi. I didn't leave myself room. We have to chunk a pi up in there. So it's pi times that. So that's going to be the solution to this problem. And shortly I will be giving you the solutions to the L'Hopital's rule problems that I sent you on an email. Keep working hard. I will see you shortly.